Okay, so we are doing the last conic section, parabolas. Parabolas. And I say parabolas later than the other three because parabolas don't have both variables squared. All the other ones had x and y squared. This one only has x or y squared. If it has x squared and y is by itself, it's going to be a parabola that opens up or down. Those are the kind that you've done the most of. Those are the regular ones. If y is squared and x is to the first power, then it's going to be an inverse parabola. It'll be going left or right. Way back when we did inverses just mean you take your x and your y and you split them. So here, this one opens up or down. This one opens left or right. So we're switching x or y. When you draw your parabolas, you're going to find some pieces of information, and all this is written in here. You're going to find your vertex. Then parabolas do have a focal point, one focus, and it's located similarly than the other foci that we've done where it's in the curved part. And that focus is going to go up if it opens up. If the parabola opens down, the focus goes down. If it opens to the right, the focus goes to the right. Good job on it today. And so on. And then there's something else called the directrix. And the directrix is a line. And it is the other direction from the vertex than the focus. So for this first one, if it opens up and our focus goes up, then our directrix actually goes down. But it's a line. There is something called the lattice rectum. And the lattice rectum has endpoints that you will find. The endpoints are on the parabola, and the line itself goes through the focus. So that's how we can tell how wide this parabola is. And I'm just going to go through it. On the front page it says how to find everything. I'm just going to go through the points like you've read all of this already. So we need to find P, and then in these equations you can see 4P is what's in front of the parentheses with the x or the y. And then P is used to find like all of this stuff. And the focal chord, the distance is 2P from the focus. So we're going to use P for everything. So our first example, x squared equals 8y. Look and see which variable is squared. X is squared. That's what's normal. Y equals x squared. That's normal. That's going to be upper bound. Our vertex would be h and k, where there's no parentheses here, so our vertex is at 0, 0. And plot that. This number that is in front of the variable that is not squared, the number in front of the variable that is not squared, is 4p. That's 4p. So you say 4p is equal to 8. When you say 4p equals 8, then you can find the p value. So what's p? If it is positive, it'll either open up or to the right. If p is negative, it'll open left or to the left, or shift down. But since this is x squared, I know it opens either up or down. This will be up. So you have that first information, and you want to start thinking about that when you use P to find all the rest of the information. We know it opens up, so the focus point is going to be up from the vertex. So the focus point is P units up in the direction that it opens. So to my vertex, I'm going to add P, which is 2, to the y value because it goes up. So I'll have 0, 2 as my focus point, focal point. The directrix is take away P from the focus. Take away P. I mean, not from the focus, from the center. Take away 2. Since we went up for where the way is opening, then I'm going to go down. If I go down, that is a y change. So I write y equals, and I take away 2, so minus 2. So I draw the line y equals negative 2. The line y equals negative 2 has to pass through the y-axis at negative 2. Then our lattice rectum, we start with the formula 2p. So you do 2 times our p value, which is 2. You get 4. The lattice rectum tells you how wide the parabola is. So when this parabola is going to open up, the width is going to be left or right. If it opens up, then the width will be left or right. So I'm going to take this 4 and I'm going to add or subtract 4 to the x value, because we're talking about wide. Going to do to the x value, but it has to be of the focus. Don't go back to the center. Go to the focus. We're going to go width of 4 in either direction from the focus. So my points will be at 4, 2 and 4, negative 4, 2. And once you have those points graphed, you should be able to graph your parabola through the vertex and the endpoints of the lattice rectum. So we are doing this at an introductory level. You're just finding this information. We're not really doing much with the information, but if you were to go into engineering someday and maybe you're doing some sort of design, you might actually use parabolas and the focus. I'm doing ever heard of parabolic reflector. Parabolic reflector, have you ever heard of one? Do you know you actually use one? Like most of you use one, like all the time. Parabolic reflector. Can you tell what I'm drawing? Yeah, it is a headlight. So here's my old blue car. I don't drive it anymore, but that's my old blue car there. So the parabolic reflector. So when you just like turn on a light, it just like wherever. But a parabolic reflector is going to focus that light in the exact path. Not only will it shine this way, but it's also going to bounce off the parabolic reflector and shine exactly where you want it to shine. That's why our headlights look a certain way rather than just going everywhere. Because you don't want to blind people driving. You shouldn't want to blind people driving coming the other way. So there's a certain direction. Those are parabolic reflectors. And guess where that light bulb is sitting? At the focus. Yeah. There's also parabolic reflectors in satellite dishes, where you have the little beep, 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 I don't know, where you're sending messages to something from the ground. It's going to bounce off the satellite and hit a specific direction that you want it to do. Or this would be the focus itself. So the focus is actually very useful to us later in life, or right now when you're driving your car. So maybe someday you'll need to find it. But for now, we're just finding the numbers and graphing them. All right, next one is y squared equals 16. So we look and we say, which variable is squared? Y. So y is squared, that's the inverse. That's going the other direction. My center for this one, 0, 0. It's either opening right or left. So I'm going to take 16 and I'm going to set it equal to 4p and solve for my p value, which is 4. So it's either opening right or left. If that is a positive number, then which way is it going to open? The right, because it's positive. Negative would be left. We use that p-value. Our focus point, our focal point, is going to be 4 to the right. So from our vertex, we plus 4, and we get 4, 0. Our directrix will be take away 4. That's going to go to the left. So that when I run my equation, since I'm going left, that's x. The line at x equals -4. The latus rectum, we use 2p. 2p. So I do 2 times 4, which is 8. And I'm looking at my graph, and I know it opens to the right, so the width is going to be going up or down. So to my focus, I add or I subtract 8 to the focal point. So I have 4, 8, and 4, -8. And then you draw a parabola. You guys should know what a parabola looks like by now when you're in pre-calc. You've done it for a few years. Picture it looks like a parabola, not an E. Okay. All right, next one. What do we got to do? Complete this square. Thank you for being the first person to actually say that in all the classes today. I had all kinds of crazy answers. So the next one, we are going to have to complete the square. But only one variable is squared, so which one am I going to complete the square with? Just the x. Make sure you put the square to both sides. So I'm going to complete it with 9 to both sides. Once I've completed the square of the x, now I'm going to have to take care of the y side. The y side should also have a parenthesis. It cannot be 4y. It just has to be y inside of the parenthesis. So I'm going to have to factor out 4. To factor out whatever's in front of that y, even if it doesn't divide by 20 evenly, I have to factor out that number in front of y. You can write your center from HK. Just make sure that your vertex, I keep calling it the wrong thing. Your vertex has to be the x value, then the y value, which seems easy right now, but when it's like y squared, when they're switched, easily make mistakes. Take your time to think about that. I'm going to find my p value, so I take that 4 that's in front of the y parenthesis, and I set it equal to 4p. So p is equal to 1. So if it's x squared, and p is positive, which way will this move in? Up. Yep.
Why do we use 4 sulfur?
It's this number that is outside the parenthesis with the y. Did you factor that number out?
Yeah. Okay.
So it's always whatever that number is in that spot. It's on the side that is not square. Yeah.
You always use 4p on the other side.
Yes. That's like the formula. Okay, so now I need to do the focal point because it opens up. I'm going to add 1 to the y value. That'll be at 3, 6. My directrix will be take away 1 from the y value. It's going to go down. So because I'm going down, it'll be y equals, and then that value will be 4. That's my directrix. The lattice rectum, we do 2 times the p value. And then we add or subtract that for the width of the parabola. Since it opens up, my width is going to go left or right. And we have to add it or subtract it from the focus. So I'm going to add or subtract 2 to the focal point, left or right. So I'll have 5, 6, and 1, 6. I do not think any of this is super difficult, but you have to like make sure you're going in the right direction and use the formula. Next page. So you look at that equation, what's it tell you to have to do? What do I do to the equation? Complete the square. It's not in the form yet, so you're going to have to complete the square. Which variable is squared? Y is the one you have to complete the square with. So we do y squared plus 2y plus squared equals, move everything over, negative 10x plus 9 plus squared. Complete the square, factor, and then once you have it factored on the x side, we have a negative 10 in front of the x. That has to be pulled out to be in the correct form. Stop me if you have questions while we're doing this. Okay, my vertex. Here's my vertex. 1, negative 1. I have to use my x values and my y value, even though they're in the opposite order in the equation. To find which way it opens, we use the value that's in front of the x minus 1, the one that's not squared, that value. You set it equal to 4p, solve for p, and I get negative 5 halves, or negative 2 halves. My p value. Y is squared, that's inverse, that's left or right. P is negative, so which way will it open? Left. The p-value is negative 5 halves or negative 2.5. So to find my focus, I'm going to go left from the center. Hello. Sure. Bye. Can you send Gregory? Push that. Oh, that's right. Bye. Did you write down the assignment? It's already in paper. All right, so our focus point is going to go negative 2.5. That's going to go left, the way it opens, 2.5. So we will be at negative 1.5, negative 1. Okay. The directrix will go the opposite way. So since I went left, now I'm going to go right, or I'm going to go plus 2.5 for my directrix. So I will have, and since I'm going right, that's x equals 3.5. For the directrix. So if your directrix goes left or right, you write x equals. Makes sense. Then the lattice rectum, we do 2 times the p-value, so we do 2 times negative 5 halves. I get negative 5, but for the lattice rectum, we're going both negative and positive, so this negative doesn't really matter. And the lattice rectum goes from the focus. Since it is opening to the left, my lattice rectum is going to go up or down, so we can make it wide. So from the focus, I'm going to add or subtract 5. I'll have negative 1.56 and negative 1.5, oh, negative 6, I'm sorry, and then 4. past me, go ahead and read the next one. I'm just going to wait for people to, make sure they've copied everything down. Go ahead and read the next one and just start thinking about it. I'll catch up to you. Let's hope so. Alright, so now we have to go backwards. We need to find the equation. Anybody visual people in here? Just me, you're not visual at all? No. I am, totally. So I draw the picture. It doesn't matter if I sketch it or if I get graph paper from teacher and graph it. I'll just sketch it for now. Write the equation of a parabola. The focus is at -4, 2, and the directrix is at x equals -6. So I'm going to go to -4, 2. There's my focus. X equals -6 is my directrix. So you remember the focus is on the inside of that curved part of the parabola. So I know that my parabola is going to be opening to the right. I also know that the focus and the directrix are evenly spaced around that vertex, so that vertex is going to be right exactly in the middle of those. So I can find my vertex. -5, 2. I know it's opening to the right. My p-value is how far I go from the vertex to the focus. Should I go +1 or -1? I went +1 because I went to the right, so my p is a +1. And I just take that information and put it into the equation. So which variable is squared? The y is squared, that's how it's opening to the right. So we will put the y value here, y -2, the x +5 will go over here, and then we do 4 times p for that spot. But do simplify 4 times p. You can do it in one step, that's fantastic. I'm doing it in 2 steps for anybody watching this video or going back and looking at notes later to find out how we got that 4. I did 4 times p. That's the equation. Next one. Focus at 6,2. And the directrix at y equals 3. If it's y equals, I go up to y equals 3 on the y-axis, and I draw a line where every single ordered pair y is 3. So the vertex has to be exactly in between those. So I know the value for the x is at 6, and going up past 2, less than 3, right in the middle. 2.5. My p-value starts at my vertex, goes to the focus. How far and what direction? 0.5 down. So what does down mean? I'm going to write -0.5 or -0.5. Either side. I'm going to take that information, put it into the equation. Which variable is squared? X. So we'll do x -6 squared. And then over here we're going to do 4 multiplied by my p, always 4 times that number. And then y take away 2.5. And then simplify. X -6 squared equals -2, y -2.5. Last one is a you try, and then I'll catch up and go over it. But you try the last one. See if you're catching along. given the vertex, and once I plot my vertex and my focus, focus is above it, so it has to open up, which means x is squared. How do I find this value of P? Jenna, how can I find P? It is 3. So it's the difference between how high up the vertex is and how high up the focus is. 3 to simplify, x minus 30 squared equals 12 times y minus 4. Question? Seem easy? Do I make it seem too easy? Is it right? Alright, your assignment is in the book. I have the book posted on Canvas, and they're all in the room. There's 5 graphs, so I have graph paper. There's 6 graphs on it. If you'd like even more graphs to do these on actual graph paper rather than sketching it, I have more graph paper if you'd like that. You can stop the video before you take pictures or whatever you're doing up here.